Ever wondered why objects move in a certain way? Chances are it's due to three very simple laws of physics. If you haven't got much time, then this is the video for you. Welcome to TLDR, Newton's Laws of Motion. Now, in short, there are three laws which define the motion of objects in a straight line: Newton's first, second, and third law. Newton's first law tells us that a body, like this car, will remain at rest or in motion until acted on by an external force, such as the brakes. Now, Newton's second law simply gives us the relationship of force equals mass times acceleration, or F equals ma. I bet you've heard that one before. And lastly, Newton's third law is a bit more complicated. It shows us that for every action, there is an equal and opposite reaction force. This can be represented when you stand up. Your weight is a force on the ground, and the ground provides a reaction force back at your feet to support your weight. Now, if that summary isn't enough for you, then in today's episode of TLDR, we go deeper into Newton's three laws of motion and some simple applications. So if you haven't worked it out by now, these laws of motion were developed by Isaac Newton. These are physical laws, which means that they have been determined by repeat experiments. Now, Newton's laws of motion describe the behaviour of objects under forces. These laws cover all objects that are not travelling close to the speed of light and have sufficient mass, so likely everything that you'll be dealing with in your physics course. Okay, let's look at what these laws actually are. Newton's first law states that a body will remain at rest or in straight line motion until acted on by an external net force. Take this car as an example. Newton's first law tells us that if this car is not moving and we don't apply a force to it, then the car won't move. Now that seems pretty reasonable. Okay, so let's say that car is moving along the road at a constant velocity. Newton's first law says that that car will remain at the same velocity unless acted on by an external unbalanced force. So when we apply the brakes to slow us down, we're applying a net force to the car to counteract our forwards motion, therefore we're actually going to slow down. Now we can move on to Newton's second law, which states force is equal to the change in an object's momentum. Now, we already know that momentum is equal to mass times acceleration, so what we're really looking at is F equals ma, which I've bet you've used before. Now, this relationship simply describes the behaviour of objects when a force is applied to them. So let's take an example. Let's take our car once again, and let's say it weighs approximately 2,000 kilograms, or 2 tons. If we want to accelerate that car by 3 meters per second squared, what force must we apply to do this? Taking force equals mass times acceleration, like we just determined, we can insert our mass as 2,000 kilograms and our acceleration as 3 meters per second squared. So we can solve to see that we must provide a force equal to 6,000 newtons to achieve this acceleration. Now, if we move on to Newton's third and most famous law, which states for every action there is an equal and opposite reaction, this suggests that for every force there must be another force equal in magnitude acting in the exact opposite direction to that original force. Now, as we described earlier, this can be simply seen by standing up. So your weight, which is a force, pressing down on the ground below, is supported by an equal and opposite reaction force, which is provided by the ground under your feet. Now, if this was not the case, then those forces would be unbalanced. Therefore, according to Newton's first law, you'd be accelerating downwards. Alright, now that covers Newton's three laws of motion. Click on the box on the right to watch the next part of this physics series looking at Newton's law of universal gravitation. Otherwise, check out our channel or leave a suggestion in the comments below if you would like us to cover a particular topic in the future. Thanks for watching and see you next time.